So we'll have some.
You're okay? Yeah.
All right.
Yeah. Okay. Perfect. Perfect.
All right.
Okay.
And I also have a lot of. Sorry, I'll have some audio clips and things like that. So
I think you should be able to run those
okay.
with the screen share. Shouldn't have any issues. So, okay. Okay. Again, good morning and welcome to this last Finley Chair seminar of this semester. As we all know, the Finley Chair seminars are made possible by a generous grant from Finley family, which support this seminar series. And what we try to do in this seminar series is to bring well-known scholars in various areas, especially in analytics, IT, AI kind of things, to talk about the latest developments in that area. And today we are very lucky to have Dr. Scott Schanke from University of Wisconsin, Milwaukee, my old school actually. So really happy to welcome him here. Scott is an assistant professor in information technology management and the director of the Center for Technology Innovation at the University of Wisconsin, Milwaukee. He got his PhD from University of Minnesota, and his research actually seeks to identify and quantify effective approaches for design and implementations of the entities representing firms and brands, customer interactions, AI-enabled conversation agents like bots and other things to casually identify and manage the detrimental alternative design characteristics. He has employed a combination of controlled lab experiments and the field experiments for his research. Before coming to academics, Dr. Schanke worked in the technology consulting area at Accenture in a variety of large-scale IT projects ranging from point-of-sale systems, security, and big data analytics. So he actually provides a good mix of practice and academics rigor. So without any delay, I'll have Dr. Schanke start his presentation.
All right, thank you so much. Well, thank you very much for that introduction. So this is some work that I've been working on actually for a few years, but it's starting to become a little bit more relevant. So this work is entitled Digital Lyrebirds. And a lyrebird is basically an animal that can kind of mimic the sounds of other animals or other sounds. And so that's kind of the reason for the name. And so this is basically some joint work that I have with my PhD advisors, Gordon Birch and Gautam Ray. Okay. So my research interests, focuses mostly on kind of this way that we interact with organizations, right? So if you think back to, the 1900s, we used to have this one-directional conversation, right? So basically, you would have print and TV media, and you would see, ads that would be, broadcast one direction to you from an organization, and you can't talk back. Right? So in the 2000s, right, we saw this advent of social media, right? And so we saw things like Facebook, we saw things like Twitter, where we could actually start having this conversation, right? Might not be, in real time, but we were actually able to have some sort of conversation with an organization. So in the 2010s, right, we've had sort of this rise of sort of these chat messaging apps in which we're allowed to have sort of text-based conversations with organizations. And now on the, kind of looking towards, 2020, we're starting to actually have voice-based interactions with AI agents through things like Amazon Alexa or IoT devices. Right? So this is kind of, what my focus is on, and how we can actually sort of, strategize effective ways to interact with customers at scale. Okay, so I'm going to play a real brief clip from not Morgan Freeman.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now, what do you see?
So that was an example of a deep fake of Morgan Freeman, right? So, initially when I saw this, I actually thought that this was real, but we're starting to live in a world in which, the things that we see in media may not actually be real people. It could be clones or synthetic copies of, people that are famous or, people that are us. So what are deepfakes, right? And more broadly, you can think of deepfakes as sort of audio or video content that is typically generated via deep learning architecture known as this generative adversarial network, or GAN. Okay, so the GAN framework involves sort of these two competing neural networks. So you have this generator that leverages sort of historical training examples to synthesize these new contents, and then you have this discriminator that basically attempts to label whether that content is real or synthetic, right? So the idea is that these two things sort of compete iteratively, and the generator basically tries to fool the discriminator. And then eventually what ends up happening is that these two things, the generator eventually learns how to produce data that's statistically indistinguishable from the real thing. And, a lot of times these, GANs or these manipulated media are starting to actually be pretty much indistinguishable from, real humans. So recently there was also a new deep Tom Cruise, which is basically a fake Tom Cruise on TikTok, in which they superimpose Tom Cruise's face and also mimic his voice to actually act like the real Tom Cruise. So what this specific talk is about today is a type of deepfake, which is voice cloning technology, right? So voice cloning technology is an audio-based deepfake. And what it does is it uses these sort of short clips of audio that can generate new audio that sounds just like the target, right? So the generated audio can contain, words that you've never, said before. And, also some companies have already started to release open and paid versions of sort of this voice cloning technology. So we have, Baidu, which has this neural voice cloning API, as well as Google, which has this custom voice beta API. So you might be asking yourself, where might consumers see this technology show up first, right? So one of the big places, that, and kind of speaking to sort of that research interest in the 2020s, we're going to start seeing a lot more voice assistants and voice assistant adoption, right? So currently 123 million US adults use voice assistants at least once per month in 2022. And a lot of these are, not just smart speakers that folks are interacting with. It's also these, voice-based assistants are showing up on phones, computers, IoT, wearables, and, virtual reality. So, eventually 48% of US adults will be kind of using this technology monthly. And it's especially popular with younger millennials and the Gen Z generation. So as sort of these folks start to become older, we'll start seeing a lot more of these digital natives interacting with, voice assistants. Okay. So something that's kind of interesting is recently Amazon at its Mars conference over the summer unveiled a new type of technology, right? So they actually are integrating this voice cloning technology inside of their Amazon Alexa. And what they were able to do is actually bring about a dead grandmother reading a story to their child. So this actually sparked a lot of outrage, but also some folks actually were pretty positive about this technology because it gave the ability for people to kind of relive past experiences and kind of hit some of the nostalgia of what grandma used to sound like. So it's a little bit of a contentious technology. So on the surface, I would think that seems somewhat like an ethical, gray area, but maybe the use of this voice cloning technology isn't all bad. So Algorithmic actually introduced a digital Einstein.
Space and time are intrinsically linked, and yet technology has not allowed us to go back in time to meet, interact with, and speak with historical figures. Until now. Hello, I am Digital Albert Einstein, an AI-powered companion you can speak to at any time. I can test your knowledge with my daily quiz, teach you about my life, or answer any science questions you have. You can find me at digitalhumans.com. So, what would you like to talk about?
So quick show of hands, how many of you would be interested in learning from a historical figure? May it be, Dr. Martin Luther King or, Albert Einstein? Okay, so at least one taker, I guess. So it would be a way to basically, using this technology would be a way to create sort of an immersive, interactive learning experience. So it's not necessarily all bad, and there are some merits to
time travel exists.
There we go. So in addition, a startup, Serance, is also introducing sort of this voice cloning technology for its in-car assistant that allows you to basically customize the in-car assistant to sound either like yourself or a family member. Okay. So we can think about some both good applications. Of course, in Dubai, there was recently a fraudster that was able to clone the company director's voice and steal $35 million in sort of a social engineering attack, right? And we're also starting to see a lot of products that are popping up to kind of block this sort of negative application of voice cloning and help kind of prevent spam from hitting your call center. So voice cloning misuse and abuse, I think there's a lot of obvious deceptive use cases, right? So the use in phone scams, political disinformation, impersonation and theft, like what happened in Dubai, use of artist likeness without their permission. I think even on TikTok, we're starting to see Elon Musk supporting certain cryptocurrencies, and in reality, it's a deep fake that's got manipulated audio. So those are all some obvious bad uses of this voice cloning technology. But something that might be more subtle, and that's what this work is about, is sort of the use of customers' voice to personalize an experience. So this could be used to exploit similarity attraction and elicit perceptions of homophily. So these are some things that are hardwired into human psychology. And this could be akin to the idea of dark patterns basically being employed to shape user decision making. So, this is kind of maybe the new world of what dark patterns might look like, where, currently from the, internet perspective, we have things like, default settings and obfuscation that make, interacting with these online technologies difficult, or, forces us to, default into, purchasing something. This idea of using voice cloning to kind of manipulate human psychology could be kind of seen in the same view, right? So currently, there really isn't a whole lot of legislation. So recently, the FTC had a meeting that discusses sort of the new frontiers of voice cloning technology and how we could come up with good legislation around this. But basically what came out of this seminar is that it's really hard for us to know what the harms of voice cloning could be, right? So oftentimes these harms come from some of these unanticipated applications. And as this technology is rapidly advancing, so too are the nefarious applications. So legislatures and the FTC are kind of playing this game of whack-a-mole in which bad things pop up and they try and come up with some sort of legislation around it. So the idea of this research is to be sort of a little bit more forward-looking. So we want to identify sort of potential negative applications so that we can protect consumers in the future. So are there any laws in place that can protect us? And federally, no, there isn't currently laws that are in place, but some states have actually started to make great strides in sort of having some of these laws that could potentially protect some of us. So Illinois has this Biometric Information Privacy Act, in which individuals actually have to consent to the use of voice prints, which is and other biometric information that can be used to identify a consumer. So the sad thing is, though, while voice cloning does take a voice print, the use of voice cloning for a downstream personalization technique is not currently covered in this law. But some folks have actually started to take sort of these class action sort of lawsuits, especially in Illinois, against some of these major tech firms like Google and Amazon that are using sort of voice prints to figure out who's in a room. Okay. Additionally, California recently released, or actually a few years ago, came up with the Bolstering Online Transparency Act. And this act basically forces disclosure of an AI agent so that if an individual is interacting with a bot, they have to know that they are indeed an AI agent, so they can't be duped or kind of led astray by an AI agent. So this is only in California, and what they do is they basically can fine you, I believe, around $25,000 or $2,500 for each interaction that you have with an undisclosed agent, right? So there has been some criticism about how this can actually be, implemented in practice and enforced. But from a federal perspective, there is no law currently like this, though Dianne Feinstein, I believe, tried, enacting or bringing a vote about this federally. This is only limited to California. So, what are the research questions here? So, one, to what extent do voice cloning deepfakes induce individuals to trust an autonomous voice-based agent? And then two, does disclosure of a voice-based agent, sort of speaking to the Bolstering Online Transparency Act, and there's been some other papers as well that have looked at this idea of disclosure and how that can potentially influence people's decision making, and does sort of this disclosure idea mitigate any trust-inducing benefits of voice cloning. So if we were to have something like this Bolstering Online Transparency Act implemented federally, would this actually be able to kind of mitigate any of these sort of dark patterns or this trusting behavior? Okay. So, some related work about this is the idea of similarity attraction. And similarity attraction has been around for a very long period of time. So it's been noted by a lot of social psychologists for decades. Attraction basically occurs when individuals appraise others as being sort of similar to themselves in some personal dimension, right? So it could be facial attributes, it could be demographics like gender or race. It can also be attitudes like personality. And this has also been documented by a lot of human-computer interaction researchers. So folks in some AI contexts like social media and computer-mediated communication and voice-based exchanges, and also in these voice-based chat interactions where we actually have some of these vocal cues like accents and other sort of voice frequencies and things like that. So there's also been some other work related to face morphs. So Alessandro Acquisti and some other consumer behavior folks have looked at similarity attraction. And what this is so folks basically, or organizations can basically take sort of this stock photo and kind of morph it with the focal image of someone's face, and in some cases have shown to have more positive appraisals of an advertisement. But there are some other work that said that this is somewhat driven by demand effects. But in this case, voices may be different, right? So if you were to look at this image on the right here, it's a very subtle difference, right? It's the self-morph doesn't necessarily look all that much like the participant, but a voice might be different, right? So if you were to kind of remove a lot of the vocal cues, or a lot of the visual cues and just kind of focus on, the voice, that may be enough information to kind of get folks to kind of feel this similarity attraction. Also, though, your own voice sounds different because of how this sort of sound reverberates through your skull. So a lot of times people can't actually tell what their voice sounds like when it's being recorded and played to them. So they might not actually know that it is their own voice, but it does sound something similar, or maybe have some of those heuristics that we look to. Okay, so our study context and how we kind of address these research questions. So we adapted a game from Scharnes and Duffenberg 2006. So in this game, so Scharnes and Duffenberg, this is an econometrica paper in which individuals play a game. And what they were interested in is how do messages influence people's willingness to trust. So this is an adaptation of the behavioral economics trust game. And so basically how this works is you have subject A. So this is the experimental subject. And what we did was we actually made the AI agent be player B. So player B is always an AI agent. And ultimately what we're interested in is whether A decides they want to play. Either they are in to play and trust the other party, or out. So before A decides whether or not they're going to play the game, B can send a message to participant A. Okay, so in the original game, this was written, But in this game, and I'll introduce sort of our experimental setup, but B can basically send a message to participant A, and this is in a voice message. So then what B can then do is decide whether to roll. So if they choose not to roll, A can end up with nothing, okay? And then if the dice lands on 2 to 6, if B does indeed decide to roll, A gets money, otherwise it's 0. Okay. So there is sort of this degree of, you don't necessarily know, why or if AI agent B is going to act, in participant A's behavior or best interest. And so there's a degree of uncertainty here. So what we did actually for the messages is we actually adapted these messages. So we didn't just come up with random messages. We actually utilized Charnas and Duffenberg's original messages that were passed by human subjects. So there were a few areas in which we had to update these messages. I think this was run when George W. Bush was president. So what we ended up doing is changing certain things that are pop cultural. But ultimately, these messages range from promises, right? So please choose in so we can get paid more. I will roll the dice. But then there's also some things that were kind of funny. I have to do laundry tonight and I really don't want to do it. So some of these sort of, empty sort of talks. So we randomized what type of message or what message folks ended up getting. So the voice cloning model, so what we did to implement this is we used a well-known implementation of a transfer learning model. So this is originally coming from Jia et al., which is a Google white paper. And this is a technology that Google does use in the back end. So they utilize sort of an encoder to create an embedding of voice. And then what they can do is they can use that embedding into a synthesizer and effectively, change someone's voice or change the output of voice. So this model uses, only 5 seconds of audio to come up with a good sounding voice. So the implementation of this study, so we didn't act, so, basically what we're trying to do in this study is we're trying to understand, what can be done currently with technology that we have. So we actually used an open source implementation of this. So this is CoreNGen's real-time voice cloning. So what this actually, see if we can, sorry. So this was actually, created close to 3 to 4 years ago. So we utilized this one as it's sort of a good heartbeat of, what could be possible given sort of, real world tools and technologies. And, this, granted, it does take a little bit of, maneuvering to get this to work on a server. And I'll show you the architecture of how we set this up as well in a minute. But basically what you can do is you can pretty much get this running on a server and, have this, set up so that it can take in audio feeds and do this almost in real time. So, so here's some example audios that we have, just so that you can see. Oh. There we go. So, so we manipulate basically what type of voice. So we have clone voices.
Choose in and I will roll. You have my word.
I'll be picking roll. So if you want, you should pick in.
So these were all generated from 5-second voice samples. I don't have the original voice recordings, or I do, but I'm not allowed to show those due to IRB. But we also utilized some random voices as well. So this was actually coming from the Libra speech data set. So we basically just randomly drew from the Libra speech data set and also constructed embeddings based off of this. So the Libra speech data set is essentially a data set of audios that come from podcasters. So there is a little bit of imbalance with the demographics. It's maybe not necessarily perfectly representative, but
this is free money. Let's go for it.
The quality is very similar between both the random and the clones. Okay. Sorry, one second here. Okay, so the enrollment process. So the enrollment process basically worked like this. So we had a subject basically dial in and read a consent statement. So it was basically a one sentence that everybody read, regardless of whether or not you were, randomized into the random condition or the clone condition. And then what we would have is a server that records the statement, assigns the experimental condition, and then returns the unique game code. And then basically the subject then takes the unique game code, and in the background we're generating the audios and things like that in real time, so that when they get to the point in which they receive a message, the audio is ready for them. Okay, so here's the architecture that we use. So I tried to keep this as vanilla of an architecture. I didn't want to stray too much away from things that people couldn't already use. So what we have for integration is we used Twilio to basically capture the voice samples. So this would capture the 5-second voice samples when the subject calls in to the 1-800 number. So we would have on Heroku something that captures basically after the individual's done giving that consent statement, that then triggers a build, as well as captures that individual and randomizes them into a condition. And then what we did was we used AWS. So I had our open source deep learning model up on a large GPU server, and basically what this would do is trigger a build whenever we got a new audio message in, and then offload that build up to S3 so that we could reference it during gameplay. Okay. So our experimental conditions, as I had sort of alluded to, so we have the experimental design in which we have basically the voice that's being randomly manipulated. So we have either a random voice, which is drawn from that Libra speech data set, and then we have a clone, which is generated off of a 5-second consent statement recorded at the beginning of the game. And then we also, kind of getting to that second research question, we manipulate whether the agent's disclosed as AI. So we either say that it is automated agent B or player B. Okay. And then, as some interesting moderators or, some interesting kind of follow-on analyses is we also want to understand how risk might influence people's decision-making, right? So we also manipulated risk. So subjects are basically provided before they play the game with sort of the history of Party B's recent gameplay. So this also is an allusion to Berg et al. That did this in the initial versions of the Trust game. But this basically gives folks a good understanding of who the other party might be. So we have 3 different types of risk conditions. So we have the high risk condition. So basically subjects are informed that the party has rolled 1 out of their last 6 times. We have no risk condition, or basically no information, so they don't receive any sort of player history. And then we also have our low risk condition, And this basically is, just saying that, pretty much the other player always rolls, or, they roll 5 out of 6 times. So we'll get into the results here. So overall, we have, the average is about 34 years old. It sways a little bit more on the female side than the male. You can see that we've got 50%, pretty much disclosure and clone. And then, as you would expect, about 33% either receive the high, none, or low risk. And overall, it took about 5 minutes or so to complete this task. So here's our regression results. So we basically used a linear probability model to look at kind of how clone-induced opt-in. So we regressed our clone and disclosure variables on opt-in. So it does appear, at least in this regression, that voice cloning does indeed influence opt-in. But then when we add our disclosure dummy, we do find that this does not necessarily attenuate these effects, which is somewhat interesting, as some of these other papers, like Shuming from Temple, kind of talked about how disclosure actually drastically influences individuals' willingness to trust and complete customer service interactions. So at least in this instance, or through this experimental setup, the idea of disclosure may not actually attenuate any of the kind of homophily perceptions. So another thing that we kind of, and you might have noticed, right, is that the clarity of some of these audios, especially because we're doing this in real time, and we're capturing only 5 seconds of audio, some of the clarity might not actually be all that great. So we did actually capture this in our survey of what their perception was of the audio, and they had to rate it basically on a sliding scale from 0 to 100. So what you can kind of see, and this basically is the same for both random and clone voices, is that there is sort of this bimodal distribution in which it's either kind of bad or good, right? So what we wanted to do is take a look at how does clarity maybe influence this efficacy of opt-in, or individuals' willingness to opt in. And as the distribution is bimodal, we created a dummy for high quality voice recordings. So basically anything that's over that breakpoint, which is 55. So as clarity becomes higher, at least initially from our from what we're seeing in the data, there is sort of this interaction between high clarity and clone. Granted, it's only significant at the p.1. But it does maybe give us some suggestive evidence that as this technology gets better, this might become a bigger problem, right? And so, it may behoove, legislatures and folks that are trying to create laws about this to start moving quicker, because this technology is basically created, 3 years ago that we're using. So then we also took a look at the risk influence on clone efficacy, right? And we see that the effect is largest and only statistically significant under the high risk condition. So that's somewhat interesting. And granted, these results are only suggestive. And I think further research might need to be done to kind of identify in which scenarios and why this might be. But what's interesting here is, basically kind of using this separated linear probability model, we can see that the coefficient between, high risk, no information, and low risk, it basically doubles, right? Granted, I think, when we actually do some pairwise tests, these aren't significantly different from each other, but at least this might be some, interesting areas for future research. Okay, and one of the things too that we did as a robustness check is just to see if maybe it's certain messages as we saw before that could be influencing this. So there was only about 80 messages, and we ran a dummy. We used fixed effects for each of these messages to see if there are some that might be enticing folks to trust more, and we actually found that basically there's no effect on any of those, and that clone coefficient is still positive and significant. So the key takeaways, so we show that voice cloning may be a viable means of inducing trust by inducing sort of these perceptions of homophily. So we find that disclosure basically by itself doesn't necessarily negatively impact trust. So this kind of goes against some of the things that are showing up in the marketing literature. Shuming Liu mentioned that this is highly negative effects. Granted, that was sort of in a situation in which it was loan renewal, so it's not necessarily the same experimental context. And then this also sort of departs from previous work on face morphs. So really great researcher Alessandro Acquisti out of Carnegie Mellon kind of found null effects, and that most of these things are driven by demand effects. In this specific case, we're actually seeing kind of the opposite here, where individuals are indeed sort of trusting that similar other. And the other thing too is that this may be sort of a dark pattern in the design of AI agents. So the use of voice clones could take advantage of some of these hardwired human biases to trust similar others when they otherwise wouldn't. Okay, so a couple directions for future research. So some things that we're working on kind of going forward. So one is one of the big advertising platforms or advertising types that is gaining popularity are sort of these audio ads, or sort of these traditional old radio ads that are being now used and kind of targeted towards specific customers and audiences through smart speakers. So this would be a very fast way to personalize your interaction with a organization, and something that you could do pretty much on the fly as well. And so what we're going to be looking at going forward is kind of how can we actually design advertising content that might be micro-targeted to you in a way that you may better engage or more effectively engage with. Another area that we're looking at applying this is political polling. So we're working on a research research area where basically we want to find out if you're more willing to give accurate representations. So if you were to have a political poll of an AI agent that's basically in your own voice, does that influence you to be maybe more truthful or more trusting versus someone that sounds a lot different than you? Could you end up kind of hiding information or not being completely truthful? And then finally, some other cool areas that we may be applying in the future once the kind of technology catches up is sort of these personalized live sales agents. So designing an entire interaction with a being, a digital human, kind of like what we saw with Morgan Freeman, that could potentially sell you products or other things like that. Okay. So that's the end of my presentation thus far. So, if you have any questions or comments or anything like that, we can do that now.
Questions for Scott? Any questions? So Scott, I do have one. So in terms of identifying where we are in the technology, so if there is a fake voice and video both created of someone, how difficult or easy to identify that it is fake versus it's real?
It's getting harder. So I think, from a perspective of things being, generated from these AI or from these deep learning algorithms, it's kind of a cat and mouse game from what, I understand about sort of the reality of that science right now. It's, folks, eventually things are going to get so indistinguishable from it being real that folks get, kind of duped. I also find myself, so some of these things on TikTok actually right now, I don't know if anybody here uses TikTok, but there are some videos that I myself, a researcher in this area, have fallen for. Where I actually end up having to go back and look it up, right? So this whole world in which we can live in, a reality that's not real, is becoming more and more of a true life sort of scenario.
Now, so most of your experiments were actually just with the voice cloning, right?
Right. So right now we're just focusing on voice and sort of these alternative ways to kind of manipulate folks. So, a lot of my research right now isn't necessarily focused on, creating, the visual portion of it. We're just focusing on voice because, I think, that is the logical next step, at least in my mind, for what's going to be interfacing with consumers. Additionally, how is it that you, and kind of getting back to that audio-based ads, right? So that's one of the big growing ad media. That's going. That's I think in 2020 it was the most popular advertising media. But the idea is that how is it that you kind of personalize these experiences, right? So if you think about, visual ads that you might see, right? So you have a lot of real estate and things that you can manipulate. So aesthetics and things like that, right? I could change, the tagline that I have in the ad, or I can change, the visual cues that I use, right? Or the image, right? With audio, you really don't have too many levers to pull, right? So ultimately, you just have the voice as sort of the color and everything, the aesthetics. So this, at least in my opinion, and kind of seeing where the industry is moving, is sort of the next logical step of how I could kind of personalize and micro-target individuals using, using sort of these ads as audio-based ads as sort of the medium that you do it.
Other questions?
I have a couple of questions.
Sure.
First off, how do you evaluate the quality of voice cloning? For example, let's say I develop a program for cloning your voice. And actually, I want to know how good my product is. Is there
right? So
to do this?
Right. So in this, granted, in this experiment, we only use sort of like a little bit more coarse heuristics to see how good the model is. I didn't include that here, but so we utilized a phonological tool called PROT, which is used to assess things like mean frequency, harmonic resonance, things like that. So those actually give you those numerical differences. And what we did was we looked to see if, is it a lot more similar to the target in the clone voice. So we basically used that, the initial sort of consent statement, and then the output, which was the audios, and we kind of measured those different sort of heuristics, I guess, about the voice, and compared that, to ensure that the voice cloning was good. I think, ultimately, I don't know if there are some, bounds to this. So, because it sounds similar, and it's very similar on, like from a frequency and the pitch that you're hearing. But, are all the paralinguistic, things captured? I don't necessarily know. And if you were to add it to be, 100%, fidelity, would people maybe have sort of an uncanny or like a gross sort of reaction to it? I don't know that whether or not the bounds. So I think, one way that you can assess though is using that prot tool. So and I have some really nice scripts that can do that if you're ever interested in kind of this space as well.
Sure, thank you. Another question is that I can see you transformer. You mentioned transformer for voice cloning. Right now, diffusion models are very hard in generation part, but the major application areas are graph, the figures. I even can see news like some scientists complain that your AI model steals my idea, my style.
Right. Yeah.
And are you planning to use diffusion models to improve the voice cloning?
Well, so for this research, we're trying to use just like what is available. So we weren't necessarily trying to build a better rat trap. We were mostly just trying to see, can we use the technology that exists to manipulate people's decision making? Right. So it's more so like we're trying to understand kind of, is this something that we should be concerned about? And, is this going to be something that we would be, concerned about going forward? So kind of that suggestive, kind of the suggestive results would show that, maybe as this clarity or as the audio quality, increases, people might, this might be a bigger problem. I do think the diffusion models would be pretty interesting, especially kind of speaking to the generated sort of, one of these things that's just kind of the pie in the sky thing that I want to try and start doing is sort of these visual manipulations combined with the audio manipulations and kind of creating sort of these personalized or hyper personalized sales agents.
Sure, thank you very much.
Yeah, thank you.
Other questions from the audience? Anyone? No? Okay, well, again, I'd like to thank Scott very much for excellent presentation. Very interesting. I think it's an technology is coming up. How do you keep up with all of that? And the dangers of some of these things, I think pointed out very, very well there. So thank you very much again. And so hopefully we will see you again in the next next conferences and everywhere.
Yeah, and if you if you're ever in Milwaukee again,
absolutely, we'll see you.
Free to
Okay, so. Great. Thank you.
All right, thank you so much.